Welcome. So in this video we will learn how to determine lactose content in milk using Lane-Eynon method. So this is a part of approximate composition. So as a dairy chemist, one should know how to determine approximate composition of milk, which include fat, protein, lactose, ash and water. And in this video we will cover how to determine the lactose content in milk using Lane-Eynon method. Now we know lactose is a reducing sugar, and if we define reducing sugars are those sugars which have free aldehyde or free ketone group in their structure and thus can reduce solutions like Fehling solutions, Tollens reagent, Benedict solution. So these solution can be reduced by reducing sugar. In other mean to say that they can reduce metal ions like copper, iron or silver in alkaline conditions which these solution contains. Now here if we see that this property is being utilized to determine the lactose content in milk. So let us see point by point. Estimation of lactose is based on reducing properties of the lactose found in milk. I told you that lactose is a reducing sugar, and definition of reducing sugars also I have told you that reducing sugars are those sugars which have free aldehyde or ketone group in their structure, thus are capable of reducing Fehling solution, Tollens reagent, Benedict solution or etc. by reducing metal ions like copper, iron or silver in alkaline conditions. Now if coming to what is Fehling solution, Fehling solution actually is a mixture of Fehling solution A, which is copper sulfate, and Fehling solution B, which is alkaline sodium potassium tartrate. Now the copper ion is the source of the copper sulfate. That source of copper ion is copper sulfate, and purpose of alkaline sodium potassium tartrate is to keep the cupric hydroxide that is formed from alkaline copper sulfate to keep it in soluble form, so that we see in the coming slides also. So if we mix both the solution, Fehling solution and A and B, which result in an alkaline solution, because Fehling solution B also contain sodium hydroxide. Now copper sulfate under alkaline condition, this is the principle I am telling you, we will cover it in the reactions part also. So copper sulfate under alkaline condition get connected to cupric hydroxide, and this cupric hydroxide has the ability to get precipitated, but sodium potassium tartrate prevents its precipitation by keeping it in soluble form by forming complex with copper. So it will form complex with copper and keep it in the soluble form, so it will behave as if it is soluble cupric hydroxide. Okay, so complex being solubles behaves react as if it is alkaline cupric hydroxide. Okay, when soluble form of alkaline cupric hydroxide. When the mixture of Fehling solution is heated, so heating is done, that is boiling for 2 minutes, we will see in the procedure. When the mixture of Fehling solution is heated, it gets converted to cupric oxide, which reacts with the reducing sugar, so that will be taken butyrate during titration and form cuprous oxide. So cupric has changed to cuprous. Cupric has changed to cuprous by the reducing sugar, that is lactose in this case. Precipitates, that is big red in color, so endpoint of titration will be big red, indicating the conversion of sugar to its corresponding acid by oxidation. Okay, so this means that reducing sugar has reduced the cupric ion to cuprous ion and itself get oxidized. That is the meaning. So itself it's getting oxidized during the reaction. Now, estimation of lactose content in milk requires the treatment of milk sample with acetic acid to precipitate fat and protein. So from milk sample, first we have to remove the fat and protein. That we will do by precipitation. So we can use 10% TCA we can use, or acetic acid we can use to precipitate. The filtrate thus obtained is treated with alkaline copper sulfate solution, Fehling solution, that will take in flask with continuous heating, and during the reaction your cuprous oxide get precipitated as brick red in color. So endpoint of titration is cuprous oxide. So your actually this is this I have written that there your cupric form is getting converted to cuprous form. This is brick red in color. Okay, titration is carried out using methylene blue as an indicator, which on reduction changes color of the solution from blue to colorless. At this stage, complete precipitation of cuprous oxide occurs in the form of brick red precipitate. So let us see this in procedure. We will see, then it will be easily understandable. We will get easily understand by seeing the reactions. So here are the reactions which are shown. So let us see this, the principle also, reactions also. So simply you have to write that copper sulfide when made alkaline get converted to cupric hydroxide, and sodium potassium protiated form complex with cupric hydroxide to and keep it in soluble form. So it behaves like it is soluble cupric hydroxide. So the purpose of sodium is it keeps in soluble form. Now when this cupric hydroxide is heated, that is when we are boiling for 2 minutes, it get converted to your cupric oxide, and the rhodesic sugar from the burette will convert the cupric oxide to cuprous oxide with the definition of reducing sugar, and endpoint will be indicated by a cuprous oxide brick red precipitate. So these are the reactions which are taking place during the determination of lactose in milk. Okay, so again repeating how to write it. So copper sulfide when made alkaline, that is converted to cupric hydroxide. This NaOH is from sodium potassium titrate, and this sodium potassium titrate keep the cupric hydroxide in soluble form. So it this complex has formed, but it behaves as if it is soluble cupric hydroxide. And then when you heat it, cupric hydroxide is heated, you will have the cupric oxide, and this reducing sugar from the burette will convert cupric oxide to cuprous oxide, which is brick red in color. Okay, now what is the procedure to determine the lactose content in milk? So first we have to remove the fat and protein from milk. So you will take 10 ml of well mixed milk in a 100 ml volumetric flask. 10 ml milk you take, add 30 to 40 ml of distilled water, heat to 40 to 45 degrees Celsius, and then immediately add 1.5 ml of acetic acid, 10% acetic acid. Mix well, adjust final volume to mark, make up the volume to 100 ml distilled water, and leave the flask for 30 minutes. After 30 minutes, by using Whitman number filter to filter paper, you filter the contents of the flask. Discard the first few ml and collect the remainder of the filtrate in clean, dry Erlenmeyer flask. Okay, so this way you have precipitated the proteins and remove the fat also from the milk, and the filtrate which you have now, you will determine the lactose content in it. Okay, so what are the procedures? So first is that we have to standardize the Fehling solution. We have Fehling solution A and B. So we have to pipette 5 ml of Fehling solution A and 5 ml of Fehling solution B into 50 ml Erlenmeyer flask using 2 separate pipettes. So we will pipette 5 ml of Fehling solution A, Fehling solution B, copper sulfide and sodium potassium tartrate. Fill the burette with the standard lactose solution. So first we have to standardize the Fehling solution. So we will fill the burette with standard lactose solution, which is 0.5%, which is having 0.5% lactose. Okay. Now heat the Erlenmeyer flask over burner or heater and keep boiling it moderately for 2 minutes. And this step we have to add obviously boiling beads or chips to be added to avoid pumping. And this step will convert your cupric hydroxide to cuprous oxide. So you will have, after 2 minutes of boiling, you have color like this. So slightly brown color will appear. Okay, now you add 2 to 3 drops of methylene blue while boiling. So you are making use of methylene blue as indicator. So if you add 3 to 4 drops of methylene blue while boiling, the color will be like this. So this is after adding methylene blue. After boiling for 2 minutes, this color, and when you add methylene, blue color will come. Now titrate the contents of the flask against standard lactose solution from the burette till blue color disappears and the bright big red color of precipitated cuprous oxide appears. So you see here bright big red of the color precipitated cuprous oxide has appeared now, and at that point you will see that the cuprous oxide suddenly settles down, providing a clear supernatant. So this is the end point of titration. That is brick red color. Now note the amount of lactose solution required for the reduction of Fehling solution. So you will able to know the strength of Fehling solution, how much lactose solution have been used to neutralize or to reduce Fehling solution, that you will able to know. So how much lactose solution has been used during the titration to reduce the Fehling solution, that you will know after the titration. Now this is the preliminary titration. We are doing it preliminary. Further titration should be carried out by adding practically all the standard volume of the lactose solution 1 ml less than the required as observed in the first titration required before commencing heating and continuing titration as before. So this is a preliminary titration wherein you will able to know how much ml is actually used. So if you are doing slowly and you want to save time and have more accuracy during the titration, so you do a preliminary titration which will in order to save time, it will save time also, and you will have the accurate point of that is and accurate endpoint you will have able to have. Okay, so you will do preliminary titration, and for the main titration you will use 1 ml, that say it is coming 14 ml, and you will add 13 ml during the titration, and then for 1 ml you will take slowly so that you can observe the endpoint clearly. Okay, the titration must be done in 3 minutes. Now this is important, that titration after boiling 2 minutes, that you have to do the titration within 3 minutes. Why? Because your cuprous oxide that has been formed, that can be reconverted to cupric oxide that we don't want. Okay, from the oxygen, that is redox potential will change, and then cuprous oxide will get converted to cupric oxide. This is one point. And second, that if you are boiling extremely, then there may happen the decomposition of the reducing sugar, thus giving the erroneous result. Third, also if you are taking time and then methylene blue then immaturely can change the color. So this is also a reason that the titration must be done within 3 minutes from the commencement of the boiling. So say X value has come for the titration for this reaction, and so X ml of standard lactose solution has been used to reduce the Fehling solution. Okay, in this titration. Now for if you want to determine the lactose in milk, here now we will take 5 ml of Fehling solution. A 5 ml of Fehling solution in 250 ml aluminum per flask. Fill the burette with milk prepared milk fluid, because we want to determine the lactose which is devoid of fat, the solution which is devoid of fat and protein that we have obtained using 10% TCA. Then add 10 ml of milk filtrate from the burette into the flask containing Fehling solution and heat to boiling. Boil for 15 seconds. Rapidly add further amount of lactose filter until a flat precipitate blue color remains. Okay, so now you say that you taken 10 ml of filtrate from the burette into the flask containing Fehling solution and heat to boiling. Boil for 15 seconds and rapidly add further amount of lactose filtrate until a faint precipitable blue color remains. Then you add 3 to 4 drops of methylene blue indicator. Complete the titration to first disappearance of the blue color by adding the lactose filtrate dropwise to red color. So red color will be obtained, that is indicating that your cupric form has converted to cuprous form. So here also your endpoint will be brick red color. Now repeat the steps as mentioned in step 1. Add almost complete amount of milk filtrate. Again this is preliminary titration, this is main titration. So again to have the saving in time and also accurate endpoint determination. Then heat the mixture to boiling, followed by addition of 3 to 4 drops of methylene blue indicator and titrate to brick red color endpoint. So here also you will get some titer value, say Y has come for the your milk filtrate. Y has come. Okay, now you want to determine the lactose content in your milk. Okay, so how will you? Okay, so let us see. We have obtained X as the titer value for the lactose standard, Y as the titer value for the milk filtrate. So we know the concentration in lactose standard is 0.5%, and we have to calculate the percentage lactose in milk. So these two will be equal because Fehling solution is common for both of them, both the titration. So we can keep these two as equal. So here percentage lactose from this will come as X into 0.5 divided by Y. Okay, now since Y we have taken that 10 ml initially and made up the volume to 100, so we have to multiply by dilution factor also, which is 100 by 10. So 10 ml has been made to 100 ml. So this will come to 5 into X by Y. So whatever titer value you are getting for lactose standard and titer value you are getting for milk filtrate, you put in this formula, you will have the percentage lactose in milk. So this is how we are driving the formula, and this is how we are determining the lactose content in milk. So as I already told you that we have for a dairy chemist must know to determine the approximate composition of milk, which include determination of fat, protein, lactose, ash, and water. Thank you.